All right, we're back. We are COMP123 in the summer 2017 semester at Centennial, and we are week 8, part 2 of our broadcast. We're still talking about inheritance. The first part was kind of more on GitHub. Maybe I'll change the name of that to GitHub. And a bit of introduction on me. So where we left off, we created our program in our person for our person class, and we drove it from our program class. Here's our person class, and here's our program driver class, and we drove or created an instance of the person class, and we made it run. But we're talking about inheritance here, and what we need to do is we want to show an example of that. And I'm going to do that by creating another type of person, a more specialized version, which is going to be called student. Let's do that together. So I'm going to right-click here. I know this is a classic example again, and I'm going to go to class this time, and I'm going to call this the student class, capital S. And the student class is going to be similar to the person class. Now remember, what I need to do with student, there's a special syntax I need, right? Whenever you see the colon, right, with student, it means extends. Remember I talked about that the child class always extends the parent class, right? Well, this is what this does. I need to use the colon here, right? So student extends. Whenever you see the colon, I want you in your heads to think extends. That's what it means. I'm extending the person class. That's what I'm doing, right? So student then is a person, but a specialized version. Okay, cool. Next, I'm going to put the comments in a second. Next, let's add in some private instance variables or fields, right? And the one that I want to add in is going to be of type string, which is going to be underscore student ID, right? Student ID, that's the difference between a person, an unspecialized person, and a specialized person, which we call student, right? Student has a student ID. The regular person doesn't have that necessarily, right? Cool. All right, cool. Next, what I want to do is I want to make some public properties, right? And my public property, the one I want is public. It returns a string, and the name is student ID. Okay, there we go. And my student ID has two things, right? It has a getter, and it has a setter. I'm using getters and setters throughout the course, so please be aware, right? So getter and setter, or the remainder anyway. And when I get, I'm going to say return this dot underscore student ID, and this dot underscore student ID is equal to value. Okay, so the stuff we've done before. Yeah? Still, I got a problem though. And the reason why I got a problem is because I have a specialized constructor in my person class. Remember? I have a non-standard constructor. I don't have the default constructor that's empty. I have a constructor that takes two arguments, name and age. Well, in order for me to make student happen, I talked about this earlier, you need to call the superclass's constructor in some way. Okay? You need to be able to fulfill the requirements of the superclass. And right now, it requires a constructor that takes two arguments, which means I need to create a constructor that takes at least two arguments and sends at least name and age back to the superclass. I need to do that. If I don't do that, my person or my student class is incomplete. Okay? So let's do that. So I'm going to go back down here. And this is my student ID. I'm going to create a new area for constructors. Here's my constructors area. And in my constructors area, and forgive me, I know I'm doing a lot of this kind of stuff today, and there's no time for labs. But if you follow me, it's going to help you for next week, or the week we get back, I mean. So I'm going to make my constructor, which is going to be a public, right? Here's my public. And we're going to have a problem for sure, because I know what's going to happen. But my public constructor is going to be called student. And I'm going to take three values now, right? Name, right? Age, and student ID. Right? Notice that I'm having a problem. If I just leave it like this, I have a problem. right? Even though I've taken 3 in, I haven't set my name or my age, which is required from my superclass. See how it has this error right here? It tells you, it says, there is no argument given that corresponds to the required formal parameter name in person string, right? And what I need to do is actually put another semicolon or another colon back here, like this. I just put it on the next line, right? I need to use the keyword base, which is calling the superclass's constructor. Remember, base class? And then inside there, notice that it asked me for the 2 parameters, which is, I'm just going to pass in name and age. And that satisfies the requirements. Why? Because I'm asking for name and age here, and I'm just passing them in. I don't have to, I'm not re-typing them here. I'm not putting name as a string. I know name is a string, so I'm taking it from here, right? And I'm passing it in. It has to be a string for my base class. If I hover over my base class, it actually gives me the constructor, all the keywords from my constructor. It tells me what I need, just like it did before when I was instantiating it in the driver class, right? The person, the program, right? Now notice I don't have to put there's no semicolon required here, okay? It's just this. That's the syntax. Okay, cool. So I'm showing you a way to create the subclass. Next, I'm going to say this dot underscore student ID. Is that what I should do? No, I should use the property, right? Student ID is equal to student ID. Now again, this is the way I do it. You might have other structures that say it's okay, use the instance variable. I disagree. An instance variable should be only used through the properties. They give you more control, and they hide the information even from within the class. Do I have to do it this way? No. I choose to do it this way for more protection, for type safety. Okay? All right, so I can start putting some comments in, right? So I can do the // again. So, and then I have my comments. I say, this is the constructor for the student class. Put that in there, and I can put something like this. I can say, this takes 3 arguments, right? Which is name, which is a string. Again, you don't have to do it this way. I'm just giving you a way of doing it, right? Age, which is int, and student ID, which is a string. Here we go. Okay, so some kind of comments. I can do the same thing from up here for my class, right? So in my class level, I can go // This is the student class. I guess I'm just putting some comments just so that you know what it is, right? Now you might say, well, it's not necessary. Why would this? We're just duplicating. Yeah, but this XML style version, notice that these are almost like XML tags, which is really what they are, right? Is a format for my code hinting or my IntelliSense. That's what they are. Okay, and I can put others. There's other things I can put in here too. For now, I'm leaving it the basics, and I got my constructor. So I got my constructor. I'm good. Maybe I want to add in another public method, a behavior that students can do that regular people cannot, or normal people won't do. The regular person, the base class, right? So these are public methods. I'm only going to have one because I don't have time. I'm going to make it public. It's going to return void, and it's going to be studies, right? And of course, I'm going to do the same thing, right? I'm going to say something like this.name. Notice I have access to name in my student class, even though it's been written in my person class, right? And then I can say something like is studying. There we go, right? So whoever the name of the person is studying, right? And again, I could put in my comments, // right? And this is the studies method. Enables the student to study. Now, this would be kind of like a placeholder. Maybe I'd have some other kind of things I'm doing in here. Right now, it's just a stub method that just outputs to the console, right? But in real life, maybe it'll have some actual effect. It's behavior. Cool. We've added in the student subclass or child class, right? This is nice, but we need to test it to see if it works. we're going to go back into the program driver class. This is the driver class, the program.cs, right? And we'll add in, we'll take this console write line for a second, right? Copy it and put another one in there. And what we'll do is we will do the following. We'll say student is equal to new student. We'll pass in another name. We'll say Bobo. Yeah, Bobo. I like that better. Bobo. And you know what? We'll say he's 20 or she is. Who knows? Right? And what am I missing? Well, I'm missing the student number, right? Which I can say 1, 2, 3, 4, 5, 6, 7, 8, 9. 8. Let's say put an A in the end. So it's alphanumeric. There we go. And then we'll say something like student studies, right? Here it is, student studies. Okay. But guess what? Student can also talk, right? Even though we didn't define talks in the student class, because it was defined in the person class, student has access to that method because it inherited it, right? It got copied into that class. That's why student is a fatter class and more specialized than person. I know I've repeated myself a bunch of times, but there's a reason for this, because this is the biggest problem with inheritance. People don't understand. It's very powerful, but it's fatter and more specialized. It has similar shape, but it's more specialized version of the parent class. Okay, cool. We've done this. Let's test it. Control F5, and then we'll put it up on GitHub. Yay. Tom is talking. Bobo is studying. Bobo is also talking, right? We can know that. That's happening, right? That's good. And now it's a great time to put it up on GitHub. So we're going to go to Solution Explorer, pin this up. We're going to click on Team Explorer on the bottom. I'm going to go to Home. I'm going to go to Changes. And I'm going to say something like added student class, right? That's what I did. So any change I make, I want to put here. And I want to do it as I'm developing. The challenge with students is they do it afterwards, right? They sit there and go, Tom requires us to do GitHub, so we're just going to put it up on GitHub. No, that's not good enough. That is just a backup. That is not working with GitHub. I want you to work with GitHub, right? Every time you make a change, I want you to put up a commit and push it to GitHub. So it takes doing this as you go. And it's going to interrupt you a little bit because you're used to writing everything at once, a lot of you, right? And that's bad. Don't write things at once. Write things in chunks. Every time you write something, test it, right? Now, I've written a lot here. You could actually, I could have done way more commits than this. For example, I could have created the student class, the shell, then added my properties, make a commit, then added my method, make a commit, then added my constructor, make a commit. And I can keep doing that in kind of this granular format. For me, as long as you make a commit every time you add a major change, I'm okay, right? But in real life, you may make a bunch more of them, right? Because this makes more sense. Please don't make a commit when you add a comment, though. Add a comment, make a commit. No. That's not a good commit. That's a commit that's bad. I won't say it. I'm live on YouTube. All right. So now we've made a commit. Is the commit up on GitHub? No, it's not, right? We're going to go home, and we're going to go sync, and we're going to push the commit up on GitHub, right? So when I push the commit, when it's successful, if I go back and look at the Mac side, right, and if I look at my new repository, you can see now that I have 5 commits, right? And my 5th commit is I added my student class. You can see a progression of how I'm building up my application. And this is why we're using GitHub, okay? I want to see how you're working in this second half. Cool. Any questions so far? So we did our first inherited class. We made our new subclass. I mean, it's pretty simple what we did. But now let's add some complications. And in fact, I know the other instructors are going to get mad at me for what I'm going to do right now, right? But I'm going to show you a really quick and dirty way to create code, right? Because that's the kind of guy that I am. I want to make it as fast as I can, right? So we're going to do something different. I'm going to go right-click, right, on my solution here, on my project. Right-click on my project. I'm going to add, and I'm going to click New Item. Come on, do it with me. And when I click New Item, I want to click over here in the search field. I want to search for diagram, right? And click on the diagram, please. This class diagram. Now I'm going to rename this class diagram, so it's going to be called, you know, COMP123 you know, and it's going to be the lesson, or maybe with summer S, I'll make it be really long, S2017, lesson 8, class diagram. And I don't need the 1. This is like adding class diagram 1. I don't need 1. That's good enough. And then click add. You're going to see this. It's going to be like this big white space. Cool. Well, guess what I can do? I can do one of these. I can say, well, here's my person class. Drag and drop. And here's my student class. Drag and drop. And look, there's that arrow, right? That arrow that points to the parent. It says, hey, student inherits from the person class. Let's go a little further with this. So I show you the power of this. I can open this up, and you can see here that you've got fields, properties, and methods. Here's fields, properties, and methods. And if I really want to go crazy, right, up on the top here, it allows us to display the full signature of the class like this. And then I can expand everything so that you see everything that's inside the class. So this gives you a nice snapshot of what the class looks like. And you're going to be like, yeah, okay, who cares? Thank you very much for giving us a visual representation of inheritance, Tom, right? But that's not the power of this. The power of this is quick coding. I want to make a specialized version of the student class, right? I'm going to call it domestic student, right? There could be international student, right? Or some other kind of student, transfer student, adult student, or I don't know, mature student. It could be different kinds of students that we have, right? But I want to make a domestic student, right? So I'm going to right click here in the white space, add new class, right? And in here, I'm going to call the class name domestic student, right? And press OK. It gives me this. Nice, nice. And if I right click, right, notice that it says there's a bunch of things that you can see. I can add a couple things here. One, I can add in a method, property, field, event, constructor, destructor, constant. I can add whatever I want in here, right? The other thing I can do is I can double click on it, right? If I double click on it, you can see that this is the class itself. It actually gives me the code right here, right? Now I want to make this inherit from the student class, right? And once I do that and save, and if I go back to my diagram, I can see now that I have a line that goes, it actually shows that it's connected to my student class. So you see that there is a hierarchy now, right? But the student class connects, sorry, my domestic student connects to student, which connects to person. So I can say that my domestic student is a student, but a specialized version. Okay? Now this isn't really enough. I need to add in, to satisfy my requirements, I need to add a couple things. One of them is I want to add in a constructor. So let's do that. So I want to add in a constructor. Right, here's my constructor. It really doesn't satisfy my requirements though. And if I pull up my class details on the bottom, there's another tab I can put up, class details, right? And notice that here's my domestic student constructor. It looks like a method. Now the modifier is public and so on, and it doesn't take any fields. But if I pull it down, you can see that it can take parameters. Like for example, I can take in a new parameter, or I can just double click on it. Now that I've added it in, here's my domestic student method, and I'm back here, right? My domestic student method, I want to get rid of not implemented. That's what this thing is, right? But I can actually physically start typing in. Now I know I need to make it so that it derives from the base class, right? I want to call the base class. It needs name, age, and student ID. It needs those things. So I need to put them in here. So name, which is a string. I'm kind of doing it very quickly, but you can see that there'll be advantage to this, right? Int, which is an age, which is an integer. I also want my student ID. Right, there's my student ID here. And to cover the requirements, I'm just going to pass those in, name, age, and student ID. I'm also going to have another property in a second. So now it says, look, it says inconsistent accessibility. This is a problem that you might encounter. It's going to say, wait a minute, you told me that my domestic student is public, right? But somehow my student is not public. Is it? Well, because we didn't specify, right? In my student class, and I did this on purpose, notice my student class does not have an access modifier here, right? Because I haven't put it in, it's private by default. So if I put public here, we're good. But now we have a problem because guess what? My student has a problem because it has more accessibility than its parent, which is my person. Now you see now we can see the domino effect of inheritance, right? Inheritance puts us in a bit of a box, right? Which can be good and bad. But now it's forcing me to put my public class of person in place, right? So here's what we learned from this experience. One, your access level has to be lower for your child than it is for your parent. So if your child has public, your parent better have public, right? If your child has private and your parent has public, that's okay. But it can't be the other way around. That's a rule, okay? And there's a reason for this. Because you're inheriting, if the child has more access than your parent, you're breaking the kind of convention you've got for parent-child relationship, right? From a security standpoint as well. Let's go back to domestic student for a second. So domestic student is okay right now, right? We haven't really taken anything in, but let's make a, sorry? Someone asking a question? Or is that me? That's me. All right, let's go to one more thing for the class diagram. If I go to my class diagram one more time, right? So we've got some stuff here, but I want to add in a property. Let's add the property in there too. So here's my property, right? My property I'm going to name as domestic address. Maybe that's the only change I have. Here's domestic address, right? Now by default, you see that my property is an integer. And I can change that here in my class details without actually coding anything. So here's my domestic address. I just have changed this from integer to a string. So I can do that. My challenge though is when I double click on this to go back to the class itself, it doesn't really implement everything correctly. Remember, all it's doing for you is just creating a scaffold, right? Just some kind of structure for you to quickly create, to draft out your class. So why use the class diagram? One, it cuts down on errors, right? Because I don't have to sit there and go through the whole add this to my, add a class to my project. I don't have to do that. It also shows relationships. And it scaffolds out stuff a little quicker. All right, so I'm going to return this dot. And again, you know what? Just to make it quicker, I did this kind of in the first class. Let's make it the simplified version of the property for now. I'm not going to have a private instance variable in this particular case, just because I want to show that you can do that too, right? So I'm going to say get set. That's okay, right? There is no private instance variable here, right? My domestic address is just a thing I can add in, right? And I'm not taking domestic address in here. Maybe I'm going to set it somewhere else, and let's add that in as a method, right? I can set it directly, my domestic address. How do I make my domestic address read only? I want to make this is not actually on your exam. How do I make it read only? So what? Get rid of set, right? It's the easiest way. So I can go to set, right? And I can't set my address. I can only read my domestic address. That's read only, right? So this is my read only property, right? So this is read only. And I could say this is a public property. Here's my public properties again. So public properties. Oh. So I can do all this the same as we did before. And this is up here. This is my constructors. A question for you, right? Should my property appear before my constructor or after my constructor? What do you think from a convention perspective? What's the right thing to do? Huh? Before, yeah, for sure. So I need to move that around. That's not required. It's just a convention, right? So this is the constructor takes 3 arguments, which is name, string, age, int, and student ID. Okay, so it does. Satisfies requirements, and I can move that, right? I can move it around. I can just copy it and cut and paste. So cut, and come up here before my constructors. Paste, right? And now I need a method. I didn't do this in the first class, but I'll do it now with you guys. Public methods That's what happens when you do the second time. It's always better, right? So you guys always have the benefit of that. Public methods, the method I want to have is public. Oh, well, you know what? Let me show you how to write this with my class diagram. Why not? Since we're here. I can write it longhand, but class diagram can do that too, right? And look how it updates, right? The class diagram updates with my new stuff. Like I added all this stuff in here, and I want to add a new method. I just go add method. I can scaffold this out. I mean, I'm doing it one at a time, but I could scaffold out the entire class, write it first, and then go back and modify it and make it perfect, right? Which is totally fine. So I'm going to call this method, you know, kind of set. We'll call it a set method. I'll say set domestic address. Maybe I want some kind of special way of doing it, right? That's my set method, right? Set domestic address. There it is. And if I double click again, it takes me back, and I can see that I have my set domestic address here. I don't know why I put it here, but we're just going to take it from here. Probably because that's where my cursor was when I left stuff off, for sure. I go down here and put it here where I think it should be, right? Now it says not implemented. Of course, I'm going to implement it. I'm going to say something like this. I want to take in, so I'm being more formal in my setting domestic. I want to, the argument that I need is a string. So I'll say address, right? And in here, what I'll do is I'll say this, you know, domestic address is equal to address. Right? Now here's something that's a problem, right? Look what I got. I got a problem, right? If I make this read only, and if I use the domestic address method, right? Now this is the one way of making it read only, but how can I make it so that you can't set it because it's private? Remember we did that as well. Can I make private set? Is that possible? Like if I did one of these, you guys try this on your exam too. Private set. Is that possible? Can I do that? Yeah. That's the answer, right? So that's kind of read-only from the outside world, but it's okay to read, or sorry, it's read-only from the outside world, but inside my class, I have control, and I can make it so that I can only write to it within my class, like what I'm doing right now. Again, which is a lot of control, right? Just to make it different. Yay. Okay, cool. So I've done this. I'm able to do my methods, and I could also put a little comment in here. Right, there's my, oops, undo. I meant to put that at the beginning just to adhere to my style. And I'll say this method sets the domestic address property. Maybe I want some reason to make it this way, like some kind of standalone method that does it. I don't have to. I can use a set accessor method. Here I'm just making it public and separate. And I want them to use set domestic address as my part of my API, right? Okay, cool. So let's take a look at the class diagram and see what that looks like. Well, it looks like this, right? It shows you get set. It shows you domestic address. That's cool. It shows all this stuff, and it shows the relationship between the other classes, right? Okay, let's run this thing to make sure I don't have any issues, right? Because adding a class is one thing, but running it is totally different, right? So one, let's run it now first before I instantiate it, because I haven't really instantiated an object of type domestic student. Now we'll do that, right? So here's my program. And notice that I have my, I'm going to copy this as well. Just add another little space here. So let's do this, right? So we'll say domestic student, right? We'll call this domestic is equal to a new domestic student, and we'll name them Mary, right? And she's 19, and maybe the 1, 2, 3, 4, 5, 6, 7, 8, 8, B, some other weird student number, and then I'll say domestic student, or domestic dot talks. So you see that even she, Mary, the new domestic student, can talk because the domestic student is a person, right? Even though she's also a student. She's a student and a person. She belongs to both of those sets, right? And if I was to run this thing, you can see that now that Tom is talking, Bobo is talking and studying, and Mary is talking, right? Very straightforward. But the idea here is that you got an intro to inheritance. The idea that domestic student is a student and the student is a person. And so therefore domestic student is a person. Okay. And the class diagram, I wanted to show you this because as we move forward, you're going to see me ask you to use the class diagram to do something really quickly because it's faster than just coding it on your own sometimes. All right, let's recap what we've done. Let's put this up on GitHub, first of all. Solution Explorer, yay. Team Explorer, right? What have we done? We've made some changes, right? We added, right, the domestic student class. Cool, we're going to commit all. Good, home, sync, and push. And we got all that up on GitHub right now, yeah? There it is, all up on GitHub. Wonderful. Now let's talk about our PowerPoint for a second. I'm going to go back to that just to recap. So what we talked about today was a couple things, right? We talked about how classes, I see classes as kind of blueprints. That's my analogy. That's my metaphor, if you will, for for classes. Classes are blueprints or prototypes, if you will, right? And they create objects, right? A class will create an object, right? Well, at the same time, if we take that approach, then when we inherit from a class, we can extend it. Remember, we use the colon to extend the class. That's the syntax. We say, whenever we see a colon next to the class name, we say extends in our mind, because, by the way, extends is the key word in Java. If you're going to program in Java today, in order for you to inherit, you would say whatever the class name is, you put the long word extends, and then whatever the superclass is. All right, and so here's an example of where the original class, here's how we extend the class. The subclass is always fatter, right? Subclass is always fatter. We talked about that. And we also talked about this idea of inheritance chains, right? Where each subclass is more specialized version of the superclass that came before it, right? Its parent class, okay? That's a very important concept. And the positives and negatives. I was going to ask you what the positives and negatives are of inheritance. Positives, it's great. We don't have to reuse code. That'd be the first thing I would think about. Negatives, right? It can break your code. You make a change, breaking change to one part of your code, especially higher up the chain, even lower down, right? And it can break your code base. You have to make look at the changes I had to make. When I made a simple mistake, right? I had to make all these changes as I went up the line, right? So that's the idea. The idea is one part of your inheritance chain can break, right? Break your build. So that's the idea of being specialized, right? We also use a couple of different ways of talking about classes, right? I'm just going to go down to that slide for a second. Oops. This one. And we use some naming conventions. Base class, which is also superclass, which is also the parent class, and derived class, which is also the child class, which is also the subclass. And for us, we want to use base and derived for C#. Okay, so you're going to see that in the documentation, right? And remember, we always create an is-a relationship between our child and the parent class. So a child is a type of parent, but a specialized type. One other thing we covered before I let you guys go, we covered the idea of GitHub and the idea that as developers, you all must start using version control of one way or another because it's dangerous not to, right? You can lose your code, you can break your build, and the idea that you sign up for GitHub, you create a local repo, right? Which is using Git, the version control system. You make snapshots of your project, right? And the project itself is held inside of or the snapshots are held in a repository that's hidden in a .git folder. You can actually see this later on. We'll explore this again, right? And then we create a remote connection to GitHub, which is our cloud provider, and we push our project to GitHub so we can do three things: backup, good version control, and collaboration. Okay? Any questions around this stuff today? I know it's a lot of stuff today that I gave you, but I need to give you all this stuff because it's going to build. Everything that I do from now on is going to build on the stuff that I've told you today. Okay? Next time we get together, a couple weeks from now, after break, there will be a lab, like I said, that involves GitHub. You need to have a GitHub link, a GitHub repo, right? A zip archive of your project files and other stuff. One other thing I think we talked about that I want to briefly talk about, not only the class diagram, we talked about the class diagram, but we also talked about, I mean, I've been using it kind of on the sly, but I've been really commenting differently, yeah? I commented differently here. I used the // I want you to take that away. And the idea of the underscore that represents private variables. Those are all new conventions for you. And that's why I didn't do any lab today. There's just so much new stuff, and you're getting to know me. So I wanted to introduce all this stuff to you today and then hammer it again in a couple weeks. Guys, thank you so much, and girls, we'll see you in a couple weeks. Please see the video, and I will create a link for the video and everything else as we go forward. Thank you.